Hey there, C# friends. My name's Matthew. I'm the C# artisan, and this is part 2 in my video on async await. In part 1, we demonstrated async await, and we looked at how it's implemented, what it really does, and why it exists, what problem it solves. In this video, I want to pick up a few of the loose threads that I left from that first video. I asked a few questions. Well, now we're going to answer them. So here we are in our test project, and this was our main test function. And just to refresh your memory, we log out that we're starting, and then we do something awaitable, and we await it. And then when it's done, we do something awaitable again, and our duration is 4 seconds, and then we end. So let's just run this so that we have this in mind. I'll press enter. It's starting something awaitable for 4 seconds, and then it finished, and then it's doing the second one for 4 seconds, and then it finished. So you can see begin, end, starting the second one, begin, and end. So the point I made in that first video is that this statement blocks and then this statement blocks, and they happen one after another. So what if you wanted to kick these both off at the same time? What if you wanted some parallel processing happening here? Well, that is totally fine. So I've got some code on my other screen, and we're going to replace this run test async with this version. So what we're going to do is we're going to create a list of tasks, and we're going to start 2 tasks, and then we're going to call await task.whenAll, which will block until all of our tasks are done. And just to keep track of them, I've added 2 seconds on to one of them. So let's go ahead and run this. Press enter. So now you see it began them both right away. The second one didn't wait on the first one, and then the second one completed, and then the first one completed, and then we're done. So you just need to create a list of tasks, add all of your tasks to the list, and then call whenAll. Now, what if you wanted to continue running when any one of them finishes? So there is a method here called task.whenAny. And just to make this really clear, I'm going to lengthen this out. So this is kind of interesting because the await is going to proceed when either one of these finishes, whichever one is first. So this creates kind of an interesting situation. Let's run it and you'll see what happens. So 7-second began, 4-second began, and the 4-second awaitable finished, and then our function logged and run async, and in fact our entire process said, oh, it's done up here. And then a few seconds after we're done, the one that was configured for 7 seconds, it finishes. So we kind of lost track of that task there. It is possible to create and run tasks in C# and kind of not keep track of them, not even await them at all. There are other ways to do that, but that's what's happened here. We've launched a task and it's just off there in the ether running, and we're really not tracking it at all. So in many cases, that's probably not what you want, but I wanted you to be aware of it. So that answers the first question that I asked in part 1 of the video. How do you do 2 things at the same time? Now, the next question that we want to talk about is sometimes called the turtles all the way down problem. And so to set this up, what I want to do is I'm going to copy a few functions over here just for us to look at. So what I've got is a series of nested functions. Function 1, which calls function 2, which calls function 3. That's easy enough. And so let's modify our test code, and let's just have it call function 1 with our duration. So no asynchronous code here at all. We're just going to call a chain of functions. So I'm going to run it, press enter, and as expected, function 1, 2, 3. No problem. So here's where it gets interesting, and maybe this is something that you've experienced. Let's say that inside of function 3, you want to do something awaitable. So now you've got a problem, because do something awaitable is asynchronous. So, okay, we say await, do something awaitable. But that still doesn't compile because this function isn't asynchronous. So now we make this one static async task, and that's good, but then it shifts the problem up here to function 2 because function 2 can't call function 3 because function 3 is asynchronous. So what do? Well, now function 2 has to become async task, and we await function 3. And it happens again. And so it just keeps percolating up the chain. So this is what I say, turtles all the way down. It's kind of like once you introduce something that is async and awaitable, it kind of cascades up so that you need to have awaits all the way down. So let's fix this. And this one has to be async. And then we can call function 2. And now it's all the way back to our main function. So what do we do here? Because our main function is not asynchronous. Now, there is such a thing, and I'm going to talk about that in a moment, as an async main. But let's just stick with your basic main function, which makes sense, right? This is kind of the entry point that the operating system is calling to launch your thing. So that's where this syntax comes into play. I can't call function 1 directly like this, but I can call function 1 dot get awaiter dot get result. And now I have made a transition from a synchronous context to an asynchronous context. I've crossed that boundary. There are a few other ways to do it, but this is the preferred way. You might see code like this, task t equals function 1, duration like that, and then t dot wait. That works. It has some possible side effects where you can get some deadlocks. It works in many cases, but this is the preferred way to do this. Get awaiter, get result. And now we can call our chain of async functions. So I'm running it, we'll press enter. Function 1, function 2, function 3 calls our long-running awaitable, and it returns. So you have this turtles all the way down problem, and you do have to negotiate a synchronous to asynchronous boundary in an app like this, which you're starting the executable. Now, if you're running ASP.NET controller code, you can just have it implement the async outermost methods for you, where your controller methods, which are the kind of public-facing methods, they are already declared as async, and that solves it for you. So I mentioned a second ago that it is possible to declare an async main function. I can't remember which version of C# supported this. It's pretty recent. So I have a version of that. So an async main ends up looking like this. And let me just get rid of, well, I'll just comment it out. I'm not going to delete it because we might want to look at it. So I can say static async task main, and then I can simply await function 1 for duration. So I believe that should compile. And it does, and we can run it to make sure. Enter, and it works. So our async main calls function 1, 2, 3, and our awaitable, and then we're done. So what's actually happening here is a little bit of C# magic. Your program and its relationship to the operating system is not asynchronous. Okay, Windows is launching this program, and it's a process, and it's in no way, shape, or form asynchronous. That just doesn't compute, right? Makes no sense. So what C# is doing is it's creating a hidden regular main function, something we can imagine that it's doing something like this, right? Like static void invisible main, which is then doing something like main, we're passing in the args, get awaiter, get results. So it's creating the synchronous one in the background, and this is what the operating system calls, which then calls this. So it's this is more than syntactic sugar. This is some like hidden magic, and it kind of hides away something that I think is kind of helpful to understand. But you can do this, and at least now you know what it's doing. So we've answered a question about running multiple processes at the same time. In parallel, we've talked about turtles all the way down. We've talked about async main functions. The last thing I want to mention is, and talk just a bit about, is what is it that really makes something like this awaitable, right? In the first video, we said that when you await a function, there's a thing called a continuation that's created. And the continuation does this bookmarking where it says, once the function's done, this is where we're going to resume from. And then I mentioned that it waits for some special magic signal to know how it's going to resume. So what is that all about? And to talk about that briefly, I'm just going to switch over here to PowerPoint for just a couple minutes. So my understanding of how a function like HTTP client dot get async works is that it's taking advantage of some low-level operating system functions. And in particular, I believe this one is using what's called IOCP, which is Windows I/O completion port. And that's a facility within Windows that allows you to begin an I/O operation asynchronously and have Windows say, all right, we're not going to block on a thread for this. You have your thread back, and I'm just going to signal you when it's done. So the magic signaling that makes this possible is, in this case, IOCP, and it's part of Windows. And if we were to dig into the source code of the HTTP client, I'm guessing somewhere along the way there's going to be some DLL import of Windows API functions that implements it. So it's kind of given to us, right? The folks who have written .NET Core have implemented these async functions in a way that makes them truly awaitable. And there are a lot of them, and I kind of wanted to list out some of the common ones. So we've already seen in system.net.http, we've got http client.getAsync, and of course post async and patch async and others, put and delete. In addition, there are other libraries like azure.messaging.service-bus. I've got a whole series on Azure Service Bus, and within that, you've got Service Bus Sender send message async, and Service Bus Receiver receive message async, Service Bus Receiver abandon message async, and many others. And in the latest Microsoft.data.SQL client namespace, you've got SQL connection open async, SQL command execute non-query async, SQL command execute reader async, and others. And of course, the one that people like to use for a lot of the examples is, oh, hey, I also got SQL data reader get field value async. Okay, the one that people talk about a lot is system.io because it's simple to kind of implement as an example. And you've got file.readAllLines async or file.openAsync append all bytes async, or filestream.flush async, and many others. So again, what you're going to notice is these are all I/O bound operations. And in the case of all the first ones, they're actually all just TCP port operations. And so I'm guessing that they all rely on some similar I/O completion port code. So there you have it. We've talked about, just to sum up, we've talked about how async await works, what problem it solves. It helps us manage our thread pool and allow us to service potentially thousands of concurrent I/O requests with just a handful of thread pool threads. And we've talked about what really makes something awaitable. At the bottom of the stack of turtles, there's going to be a method like this that uses an operating system level function to help you get that magic signaling, which makes this all work. Okay, I hope this has been helpful and that you now really have a good, thorough understanding of async await. And I will await seeing you all next time. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.